Hello, everyone, and welcome back to a new episode of Advent of Code. We're going to do day 7 today. The sum of its parts. You find yourself oh, that's right, we made it. We must be in the year 1018 now, right? You find yourself standing on a snow-covered coastline. Apparently, you landed a little off course. The region is too hilly to see the North Pole from here, but you do spot some elves that seem to be trying to unpack something that washed ashore. It's quite cold out, so you decide to risk creating a paradox by asking them for directions. Oh, are you the search party? Somehow you can understand whatever elves from the year 1018 speak. You assume it's ancient Nordic Elvish. Wow, 2015, a reference from... I'm going to just go look real quick, because I did this one, but it was so long ago. Oh yeah, the instructions were written in Elvish and we didn't understand them, right? Yeah, okay, very funny. Could the device on your wrist also be a translator? These clothes don't look very warm. Take this. They hand you a heavy coat. We do need to find our way back to the North Pole, but we have higher priorities at the moment. You see, believe it or not, this box contains something that will solve all Santa's transportation problems. At least that's what it looks like in the pictures and the instructions. It doesn't seem like they can read whatever language it's in, but you can. Sleigh kit. Some assembly required. Sleigh! What a wonderful name. You must help us assemble this sleigh at once. They start excitedly pulling more parts out of the box. The instructions specify a series of steps and requirements about which steps must be finished before others can begin. Okay, so I guess we're topologically sorting this, basically. So, of course, these are very easy to parse. Visually, these requirements look like this. Your first goal is to determine the order in which the steps should be completed. If more than one step is ready, choose the step which is first alphabetically. In this example, okay. Interesting. So it doesn't actually seem very complicated. What I'm interested most in is how large is the input? A 100 lines. So there are... And there's fewer than 100 steps. Well, this seems like a naive solution would be fantastic, right? It takes less than 10,000 operations. You just compute a set of... You maintain a set of all steps that have been completed. And then you iterate over the rules, looking at each one's second element. At its second element? I don't know. I mean, we can build the graph, right? Is that worth the trouble, or can we just do things in a sort of dumber and simpler way? What would be the ideal structure? Suppose that a magic fairy were to come by, an elf even, perhaps, and offer to process this list for me. And say, you can have it in whatever data format you want. What would that be? One obvious thing is a map where the key is a step, and the value is all the steps that it depends on. Right? Then we could iterate through that list, find the elements which have no dependencies currently. Of those, find the one with the lowest or the earliest letter and perform it. And also remove that entry from the map. And then I guess we need to mark that step as complete somewhere. So we have to have like a... Yeah. We have to have a map of like... not requirements exactly, but constraints that are still in place. And also a set of steps which are done. And then we can iterate over the constraints, comparing each rule against the steps, or the already finished steps, and find the earliest one that can be completed. I'm going to get up for like 2 seconds to turn down the heat. It is hot in here. Okay, I know I said 2 seconds. It was actually longer. I ended up going to get a drink as well. Normally, I don't know. Usually, if I have to get up, I edit the episode. But that was such a short one. You guys can just sit and wait. Sorry. So, I think that is a pretty reasonable... If we had that input format, that would be great, right? How hard is it to produce that input? It's always a little bit tricky to build graphs like this in Haskell because well, in a functional language, I should say, in general, not just Haskell specifically. You have to be careful because you can't just easily look up... Well, yeah, you totally can. Yeah, it's really easy. Yeah, okay. I take it back. Everything's easy. All right, so let's get started, I guess. I want a map and a set, so I clearly need containers. And the other thing that I want, well... Yeah, this is a good time to try out another new library, because I expect it to be really easy, and I want an easy. Basically, I'm looking for a way to parse the input, right? Which is just really, really simple, and we could just honestly like do this by hand with just like words, and like look at the second and the third, fourth, fifth, sixth, seventh, eighth word in the input, and like that would be all we need. But I was complaining about how hard regexes were to use in Haskell, and someone said, hey, why don't you try regex applicative, which is not at all like an ordinary regex library, but one that is a lot closer to parsec, while having only the power of regexes, so you can't accidentally build very expensive parsers. So I'd like to try that. Regex applicative. Here it is. And I had a look through it, and it performs in guaranteed order n, because it like never considers any state more than once. It uses the like actual NFA to DFA translation rather than using a backtracking engine like PCRE would. And it uses parser combinators to build up the regexes, just like you do with parsec. So here's the API reference and some examples, both of which I'm happy to have. And we want to depend on how do I paste? There we go. So back to the, no, don't click on the Git history, examples. So there's just a few like operations here, basically. String and char and whatever. Like, in fact, what are they all? Okay. And RE... Ah, right, and it doesn't just apply to strings. It takes S. So S is the type of symbol that it recognizes, I think. And A, yeah, it recognizes symbols of type S and produces a result of type A. Cool. So just like parsec, because it's applicative, we can actually have the parsing step return a value of the type that we want, rather than just like returning a string and a list of matching. There's like no such thing as capturing groups. You just, while you parse the thing, you then fmap it to be the value you want it to have. So these are the operators that we have. We have fmap, of course. We have pure. We have the applicative operators. We have the alternative operator. There's an empty regex. Many is 0 or more. Some is 1 or more. Is that all? No, there must be more. I see. These are actually all just... These are not part of the library. None of these are part of the library. They're all just part of applicative, alternative, and functor. Right? Yeah. Empty is not one I realized. What the heck is empty? Ah, for an alternative, it's the empty that doesn't do anything. Okay. So we have a symbol that takes like a single symbol, which for us will be a character. P symbol, which is matches a symbol that specifies a predicate. M, which either returns nothing or returns just a value you want to return. So this msim is basically just psim with like an fmap to constantly a. Anysim is anything. That's just like psim of constantly true. String is a list of a's. A list of symbols. And there's greediness, which I don't expect to care about at all. Few comap. I don't need a comap in my life. With matched returns the matched symbols. We don't need that either. Match is the like function to actually do things. And it's basically got this infix alias of equal tilde. And it matches the whole string. Okay. Find first prefix. We won't need, but find longest short. Wow, that's cool. There's different ways you can ask to search. Huh. Okay. Well, seems simple enough. I don't think I need any of these examples, to be honest. I already know how to work with applicatives, and this is just a few more operators for building regexes, so... Why did it ding? Because I see. It dings when the other window changes, I guess. You guys can't hear the ding, but it made a little dinging noise. Okay, so what do we need here? We need import text regex applicative. And I don't think I'll specify an import list for this. We really just, well, I just need like string, char, and like that's it. Or not char, sim. I just need like, yeah, string and sim. And I guess I also want a match operator. Everything else comes from control applicative, which I believe all of it is already imported as part of Prelude these days. Or I don't know, maybe you have to ask for some of it. Yeah, okay, so it is import control applicative. I don't actually know which ones we need. I don't think I need any. It's so simple. Yeah, that's in base now. All right, I don't think I need any of it, in fact. So let's just have parse. Well, let's write data rule of A is a rule I guess, like, do we want it to contain a single requirement? I guess we do, right? Yeah, so it's just a rule of goal and requirement, or prereq, let's say. Prereq, both of type A. And we'll be instantiating this at char, but maybe I'll want to fmap over it or something, right? And a well, I don't really need another type for that, I don't think. Let's just write a parser that parses a line and produces a rule. And so let's say the input is a list of rule of char. And read rule, yeah, where read rule is, I actually won't even bother specifying a type because it'll be figured out by inference. And like, that's usually okay for local functions. You don't ever have to specify the type, but it's kind of nice to do so. But here I would have to import the RE type as well. I'm like, why bother? So read rule of S is what are the order of arguments to the match operator? It takes a list of symbols and a regex and returns a maybe. So I guess it should return a maybe input. Yeah, I guess I should take lines out of here. I don't know, this whole, like, I defined this input thing as, like, a way to make the skeleton work, and, like, almost every time it turns out not to be that useful. So I'm going to just skip that. So read rule is no longer a thing. We just have parse now. Parse S equals S. Well, I guess in fact we can then say parse equals partially apply the match operator to a regex. Where regex equals what's our input format again? Oh, I don't have that open yet. String step sim, or any sim? Right, that's what I actually want. Was it called any sim? Yes. So step any sim. That's right, rule. String must be finished before step any sim. String can begin. Expecting one more argument. Why? Oh, it's maybe a rule of char. Look at that, it type checks. All right, well, this whole rule of char thing kind of sucks, doesn't it? I'm just gonna like get rid of this type parameter. And now suddenly it no longer parses. Okay, what's the type of this? Char to maybe rule. Char, oh, list of char, which is a string to many rule. So why is it only lighting up this string? All right, let's put in some, I don't know what the precedence of all this stuff is, and maybe that's the problem. It was. So let's try now. This won't load, but it got as far as it did. And now I can say, let's call parse of this. Okay, yes, very funny. No instance of show. Haha. What a dummy. And it returns just a rule where the goal is G and the prereq is X. Okay, well, I got those backwards, huh? We'll just do it this way, and then it matches. Nice. So something that feels basically like parsec. But instead of do notation, we have to do everything with applicative, which is kind of a pain. It might well be worth turning on applicative do to get us do notation for applicatives. As long as we don't use anything that actually needs monad, it can make that translation for you. But okay, for this simple one, it's pretty easy. So I guess what I can maybe do to make this a little clearer is this. Is that clearer? I don't know. It probably is better like this. Just to say, like, here's one argument, here's another, and in the middle is any sim. Okay, cool. Well, we did that. That's nice. And we kind of want to build a rule map out of this, right? So let's take... Let's add m and figure out what type that should be, right? So rule graph is a function that takes a list of rule and produces a map from rule, no, map from char to set of char. I don't even really need a set. It can just be a list, right? Because I'll only be iterating over this. Well, I guess there's probably like a more efficient set difference, isn't there? So combine unions difference Because what I want to do is, for each rule I'm considering applying, take the difference of its prerequisites with those. No, I don't need to be that specific. I can say, are its prerequisites a subset of the set of things we've already done? Is there like a subset operation here? Is subset of, it's order n plus m. Compared to, for example, what we were looking at a minute ago, combine. Yeah, I mean, it seems like that's more efficient, yeah. Okay. So we want a set as well. M.map from char to s set char. Rule graph equals from m.from list with. How do you union? S.union, of course. Of do rule prereq. Well, no, this is silly. Are rules. And then return, let's see, a pair of. Now we want the dependencies. Yeah, so we want goal to be the key, and the value should be s singleton of prereq rule. Okay, that seems good. All right, so now we've traversed parse. We've got now a maybe of all this stuff. Fmap rule graph. Fmap this stuff. And so part one now is going to take a type rule set equals this. Rule set. And this is now going to require as input a rule set. Okay. For change, the types all line up. Great. When you're done performing surgery and like there are no obvious holes in the patient, you're in good shape. I mean, there should be some, like the normal number of holes, right? None that you recently cut open. They should still have eyes and stuff. Ears. I mean, that's got to be like number 101 in surgery. Like, if the patient doesn't have ears anymore and you weren't doing an ear surgery, like, you probably should get another career. So what do we do next? We have to write part one that takes this rule set. The magic fairy just arrived and said, "Here you go. Here's your, all this stuff." So what is it supposed to produce? It's supposed to, in fact, produce a string. Well, yeah. Is null the way you look up whether a map is empty? I think so. Do I have an open? I don't. Haskell data map. No? Oh, right. It's data map strict. Well, I should fix that, huh? Yeah, so null. Okay, great. That's all I needed to know. But apparently I also needed to know to use strict, of course. If there are no steps left to do, then we must have... there's just no more steps to do. And then we're going to have recursive calls that eventually boil down to giving you an empty rule set. Otherwise, equals... let's assume the existence of some function that chooses next. Let's see equal choose first of rules in C const to part 1 of rules. How do you subtract from a map? Deletion. Delete. Delete a key and its value. Okay, I guess that's all. See. Wait, so why is this lighting up? I understand this. Oh, it does want the other order. All right, well, let's just do it like this then. Cool. Now that works. Where choose first. Oh, that's kind of weird, isn't it? I don't actually have to pass it rules. Rules is already in scope for this function. Maybe this should be a global function and then I should pass rules to it, but I don't know. For now, I just won't. In fact, I don't need to let in anymore, right? First eligible. Our first eligible equals well, I want to compute the minimum character among a set of characters, right? So minimum imponert minimum map so I want to look through a map, convert it to a list, and I think I want to use elms. No, I want to use assocs to give you the keys and the values. Minimum of, I don't know, do. Why not? Do. How can you go wrong starting with a do, right? So our rule set is going to take a goal and a prereqs from the assocs of rules. Ah, right. There's a trick, which is that part 1 needs to also track the set of things that have already been done, right? So I can't just have a single argument, which is rules. I need to also track how much has been done. So actually part 1 is go of s.empty, where go of done and rules is all this stuff. And I guess I actually have to put a where here as well. I can't share the outer where because it's closing over rules, which is only in scope inside of where for go. Okay. So instead of calling part 1, I have to say go of s dot insert. God, the first eligible is just such a long name. Well, let's call it C. So S insert. Hello, why? It takes an item and then a set, just like delete does. Done. So once we find a character that we can, a rule we can, a step we can perform, we add that step to the list of things we're doing in that order. We add it to the set of things we've already done, and we delete the rule for how that step needs to be done from the list of pending work. Okay, now we can finish writing this. So we have a goal and a prereqs. And we need to guard that prereqs S subset of done. What are you highlighting this for? S is subset of, that's right, is subset of. And we need guard from control monad, import control monad guard. And finally, just return pure of goal. Right? And this actually type checks, so that's pretty cool. Is it correct? Who knows? There is a problem. It's not correct. There's at least one problem. The first problem I see is that for steps which our goal, if there is a step which doesn't depend on anything, then it will never be listed in the input, right? And therefore, like, we need to start with some, at least one rule that has no dependencies. And there clearly can never arise such a thing from our current implementation of rule graph. So I think we have to do a bit more here. Let's let G, I don't know, be this, whatever. Really? Is this where it should be indented to? I really don't like it lining up with the equal, but I guess it should be at least, it should be 2 spaces to the right of the end of the beginning of the identifier that you wrote. So that is how I wrote it, in fact. So let's actually not do this as a let, let's do it as a where. Where graph equals this. And what we need to do is iterate over rules again, adding any which don't have any prerequisite. Adding the goal, no. Every rule that is the goal of a step we've already added. But any rule which is only the prerequisite of steps we haven't added. So we have to add those and give them 0. Give them an empty set as their prerequisites. So this is data map strict. And I want to insert, I think. Insert, if it's already present, the associated value is replaced, which is not what I want. I want the opposite. I want something that says if it's already there, and I could build that out of insert with, of course, but alter? That's way more general than I need to be. Size, combine, union with. Union takes the left biased union. It prefers T1 when duplicates are encountered. Okay. So what I can do is build a second map that just contains a bunch of empty rules and union it with the original one that has real rules. And as long as I pass the union, or the real rule first, let me just double check what T1 and T2 is. T1 is the first one, so T1 is preferred. So as long as I pass the real rule set first, graph union with, no, just union. M union of goals, let's say. Not even goals. Well, sure, we'll call it goals, whatever. Goals is m dot from list of. Actually, is there like a better version of from list where you can just say that all values should be constant, or should be construction empty singleton from set from list with key from list with. Okay, there's not, but it's not a big deal. We can just pass like an empty set every time. Of we want Yeah, prereq rule. Yeah, actually, this is probably nicer as a list comprehension too. It's basically like identical to what I'm doing here, so I don't know why I kind of felt like this one should be. I mean, it's gonna be shorter, right? For rule in rules, right? And so we could have written this one in the same way. I feel like personally just more comfortable with do notation than list comprehension, even though they're equivalent. I just kind of like it better. But let's suppose that we did make this small change. What would be... Actually, this one doesn't need a $sign, but this one does. So, like, it's a bit long, isn't it? But I mean, it's a long line, but it's a small number of lines. And I don't know. Wait, this doesn't need a $sign. Why would it need that? Yeah. So I don't know. I think this is fine. So let's see what happens when we run it. There's still no type errors. Like, what could go wrong? Stack exec AOC Day07 exe. Error undefined. Well, you got me there. Part 2 equals 0. Why is this upsetting? Oh, right. Hey! It's a list! Incredible. What do you think, Advent of Code? Did we do it? That's the right answer. Great. That's like... I mean... It's a pretty complicated thing to have written and have it work on the first try, isn't it? You know, this part 1 is, like I said in the last video, it's only like 5 or 6 lines, or 6 or 7, but there's a whole lot going on, and you're working with like complicated. Well, the types aren't that complicated, but you're doing fancy things with them. With well, you're not even really. Not even really doing anything so fancy there either. Like, honestly, this whole do comprehension could just be a list comprehension as well. But as I mentioned, I kind of like list comprehensions a bit less. Okay, well, sure. I guess there's not actually that much happening here, but it still felt like an achievement, so I'll take it. No. Day 7, part 1. Okay, let's look at part 2. As you're about to begin construction, 4 of the elves offer to help. The sun will set soon. It'll go faster if we work together. Now you need to account for multiple people working on steps simultaneously. If multiple steps are available, workers should still begin them in alphabetical order. Each step... Are you kidding me? Takes 60 seconds plus an amount corresponding to its letter. Okay. So there are 5 of us working on this. Uh-huh. Each row is... Well, yeah, I get it. I don't think I need the example. I understand what they're telling me. Each second column, how many Seconds have passed as of the beginning of that second? What does that even mean? Oh, the second with a capital S. I thought they meant the second column, this one. But no, the second column. Each worker column shows the steps that current worker is working on, or nothing if they're idle, which they should only be at the... Well, actually, that could happen anytime if there's just nothing to do. Huh. Well, I'm glad we built the fancy map instead of trying to, like, half-ass things. Because now... Gosh. It's still not easy, is it? But at least we have, like, a proper data structure to work with, and we're not just doing something weird. So, okay. Well, better get cracking, I guess. So... I guess what we need is to also maintain a list of pending operations. Now, yes, this I figured he would be clear here. It is possible to have two steps started simultaneously. If a step that, like, was blocking both of them finishes, then they both take off. So we can't just assume there will be only one to perform. So we need, like, a list of... pending work that keeps track of how many... Oh, you guys didn't see when I highlighted, but here. I highlighted this. It's possible when C finishes, both A and F start. It's not like A starts and then on the next cycle F starts or something. Okay, fine. There you go. You saw it. Very exciting, I'm sure. We don't need to maintain our current second number at all. We just need to maintain how many seconds are left on each task that is currently pending and what prerequisite that task will fill. Once that number hits 0, we'll remove that, we'll add that finished task to the list of prerequisites that have been completed. And then we'll filter, we'll search for new tasks to begin. So we kind of need... We need to model the workers that we have. Is it better to just have a list of workers? No, that's kind of a pain. I think it's better to track a number of workers, treat them as fungible. And when a worker starts working, we decrease that number by 1 and add a pending task. The tasks are what we want to model, not workers. So let's define data task is a task of job, which is a char, and remaining, which is an int. Int makes me uncomfortable. Type time equal int. Yeah, I know. So Part 2 then needs a few more parameters. Part 2, well, it doesn't. Its go function needs more parameters though. Go sempty. Gosh, this is enough parameters. We should maybe model it as an actual proper data type, just containing like basically effectively a tuple of them. But let's see. We need an sempty, a number of workers, which is 5, right? Me and 4 elves. 5 workers, yeah, okay. And the empty set, empty list is fine, which is the pending tasks. Where go done idle workers. Well, let's just say workers, right? And pending equals. So the question is, should these, no, not equals, rules equals. The question is, should I lift these 4 things into a new type somewhere? If they're only going to be used locally, it doesn't seem that useful, but maybe it would be. I'm betting no, though. And it probably isn't equals, right? It's going to be if null mnull rules and null pending, we're done, right? Yes. How long will it take? It's going to be a little bit, I need to be careful with how I transition, like, from a task being pending to something happening. And I don't need every recursive call to go to actually consume any time. Right? I'll just, if I find a task to perform, I'll give one task away and then recur immediately to go. And I'll only progress if there are no tasks or no workers available. Okay, yeah, so this is just empty string. Let's see. What else? Go... Oh, no, I don't need to write this again. If, what else? If rules is null and there's something pending, then I should advance time. But that's not what I should do first. I should first check to see if any jobs have been completed. Which means to look over the pending list. And then call go recursively. What's the right way to do that, though? How do you... All right, Hoogle to the rescue, I guess. So I have a list of A and an A to bool, and I want out maybe an A. There it is. It's called find. Returns the leftmost element of the structure, matching or nothing if there's no such element. Great. So that's what I want. And it's in data list. Yeah. I don't know the right way to incorporate this into a guard, though. I mean, I can have idle worker be like, I can have a where clause for idle workers, like where idle worker equals find. We pass the predicate first. Equals 0 remainder of pending. Why is this where failing? Oh, it needs to be indented more. Why are you upset? It's not returning the right value? Yeah, it should be a string. Okay, this type checks, but is obviously not finished. So fine, like I've got this idle worker. How do I incorporate that here? Like, I mean, I guess I could say is just idle worker, but that kind of stinks. Like, I kind of want to say, like, if this happened, then return this. Otherwise, case match on idle worker. But I need to make sure that I can continue following through otherwise. Can't, like, right? I mean, I guess is this the kind of thing that view patterns are for? Haskell view patterns? Like, what is the deal with those? I never figured that out. Never had a reason to use it, but maybe it is relevant here. So view pattern is a way of pattern matching against values of abstract types. God, this fucking example. Every time I see this, I have no idea what they're trying to say. Like, whether this is part of... This isn't actually part of the definition of views. But it's really confusing because they chose words like view and type view and arrow when, like, view patterns are all about arrows and types. Okay. So calling the function view. Okay, this seems fine. So how do I turn on view patterns? I mean, I guess I can guess, right? It's kind of has to be this, right? So what I want to do is say let's see, I take the name of the thing I want to match against. Arrow just W equals, now let's just test, is that legal? Probably have to restart because we have a new language. Pattern syntax in expression context. Well, yeah. That's true. It is expression context. I mean, am I just supposed to say is just idle worker? Like... This, like, this sucks, though. It's so bad. Because I want... There's, like, a number of conditions that I want to check. But they're not all easily expressible as Booleans. I'd like some of them to be pattern matches, you know, or you know... Well... What if I change the structure a bit? No, because I don't want to do a case match on 5 argument on like a 5 tuple. That stinks. All right. I mean, is there something else that's kind of like find that might help me somehow? Not really. Okay, so maybe I'll just have like a single thing here, and then I'll have some more sub pattern matches later. I'll say otherwise equal case idle worker of... I really, really wish I could like indent this less, but apparently I can't. Well, jeez, this... Ugh. All right, is just idle worker equals let... I know, well... We'll say, oh, that's not even what I want to do. I don't want idle worker. This isn't idle worker. It's called done task. So if there was a done task, then we should look up its job. And we're going to call go recursively. Equals go s dot insert done task done and workers plus 1. We have one more worker left. And remove... No, there is no remove. Filter not equal... So we're going to look up the job if there was a task that... Yeah, okay. Filter not equal done task... of job on the pending tasks. And finally, just the existing rule set. We haven't popped any new goals off. We've just completed one. Why is pending upset? Oh, I spelled it pendings. Why is job a maybe? Am I missing something? Pending's a list of tasks. Alright, maybe it just doesn't know what the deals with is just. I have to import that, of course. Import data.maybe is just. I really hate using these Boolean functions on maybes, which are just much more amenable to pattern matching. So the second argument... Okay, so pending is a list of tasks. Ah, done task is actually a maybe still. We didn't actually extract it. So we can call from just, which like really stinks. Okay, I mean, I can go back to the otherwise equal case. This of just and what is the order? The job is first. Job. No. Just task job 0. I mean, I guess, but I'll just pattern match here of like this. And if it wasn't that, then it must have been nothing. So there was no task to do. No task was finished. What are other things that might have happened? So we weren't done. We didn't finish a task. What if there is a task that is now eligible to run? That's the other thing to check. Nothing. And yeah, this doesn't actually couldn't mask task with char. Oh no, this was actually correct. Oh, but I can't call it job because that's shadowing. Let's call it J. Okay, so this actually is back to type checking now. Like, we haven't messed anything up that badly yet. So if there are no things and workers... Wait, is there a... No, there's no positive function. We should just use workers greater than 0. And... Okay, equals case. We need to find this, like... We need to write a function now that finds maybe an eligible job. So runnable takes a rule set and returns maybe a character. So what we can do is say runnable of rules equals list to maybe, which is in... We don't need isJust anymore. That's nice anyway. List to maybe of do this. So for all the lists, all the rules in the set, which are done, so we need a done here, and an s.set of char. I mean, honestly, we can be a little more vague here, right? Say eq a ord a. Just be more general because you can, right? Well, it doesn't work because rule set only has chars in it. If rule set were parameterized, which arguably it should be, but I don't want to mess with that. It's just kind of a pain for no real reason. List to maybe dot sort, and that's fine because it's just a list of characters. We'll sort it, and the lowest one will come first. Okay. So now, just C equals runnable rules done. This will fail the pattern match if there were no runnables, but that's impossible for part 1, so that's fine. Case runnables rules done of. This code is marching farther and farther to the right. If it's empty, oh whoops, this needs to be in. Then that's easy. We can just say, all right, well, there were no new tasks that just completed, no new tasks we can start, and we weren't done. Therefore, we'll just go done workers and map tick, which we'll define in a moment, of pending and rules. Otherwise, there was something to do, right? Just C in Haskell, characters cannot be, you can't do math on characters. You have to convert to an int. Okay. So let's define a function called time needed char int. I already have time, don't I? Yeah. So let's return that. Time needed of C equals 60 plus ord of C minus ord of A. Or is that, I might have that wrong. It might be 61 we should do. So A is 60 plus 1. So this should actually be 61. So for A, this will result in 0, and it'll be 61 plus 0. For B, it'll result in 1, and like we're fine. Okay. So what we should do then is go again. Where done is still the same. Workers, we have one fewer. We've just dispatched a worker. advance time, we'll call this. We're going to need to actually reuse this. Where advance time equals this. Okay. Go done. Workers -1. We've just dispatched one. We have to add a task to the pending queue. Which is going to be something consed onto pending. What are we consing onto pending? A task of C and time needed C. Cons to pending. And the rules will need to be adjusted as s.delete, no, s.insert, no, not the rules. Yes, we need to m.delete, rules is a map, m.delete C rules. And finally, otherwise, there were no workers available to dispatch. It's kind of a complicated state machine, isn't it? Tick needs to take a task of J and T and return task of J and T -1. This is going to be hell to debug if it doesn't actually work. I'm not sure what I should have done differently. Like, well, no, I know exactly what I should have done differently. And in fact, maybe I should do it now. And that's the thing I suggested doing earlier. I should have lifted these 4 values into an actual value level map. Like, not a map, a record. I was thinking in closure terms briefly there. A record, a struct, whatever. So that part 2 can emit a list of all the states it has visited as it goes through them. And then when I see it take a wrong step, I can inspect that and see why. I'm not going to do that yet, though. I just want to, like, make sure it compiles and then try running it and see what happens. Right now it doesn't compile, so only one error is kind of surprising. And it's here. Wait, what? Oh, I didn't put the extra arrow in. Why is sort actually in data list? It is. I figured it would be in prelude, but okay. Task, I accidentally capitalized the J here on line 47. There's a button for like go to the next in Intero mode. Is it like control X meta P? Control X P? No, who knows what that does. Help, show me Intero mode here. X H, what can I do with control X? Man, there's a lot of dumb stuff. All right, how about what other bindings do I have? Intero go to, Intero apply suggestions. So it's not actually an Intero, it's like a fly check mode. Fly check, next error. Control C bang N, are you kidding me? Control C bang N, Control C bang P. Okay, whatever, fly check mode. I need to import that from data char. Apparently import data char ord. I knew that, but I just didn't think of it. C bang n? What in the world? Runnable, please. And this should be nothing. J. C bang n. There are none. C p n? No. C bang p. No more fly check errors. It compiles. Goodness gracious. What happens if I do this? Oh, I forgot something rather important, which is to produce the output. But notice it got to the end. It scheduled all the tasks. So, like, I mean, honestly, how upset can you be? It's in this case. When we have something runnable, we need to say cons 2. There you go. It's a different... No, is it the same order? No, it's different. Look. GDH versus GOS. I didn't accidentally paste any quotes or anything. That's not the right answer. Okay. But, fine. Exciting progress. So let's just commit this for now. I don't need view patterns, you weirdo. So don't commit that part, please. But the rest seems good. Day 7, part 2. Compiles and runs, but gets wrong result. Okay, this has been a long video. And on the one hand, I want to just like go off camera for a while here. So I don't really know exactly how long it's going to take to figure out what's wrong. But also, like, when I do get back, it'll be super, like, there won't be much to do. So I don't know. Maybe I'll just include the conclusion of tonight's thrilling episode in tomorrow's video, maybe. I don't know. You'll see. Maybe you'll hear from me again a few seconds from now, and I'll edit the videos together, but I doubt it. So probably you'll hear the conclusion in the next episode if things go well. Thanks for watching, and I'll see you next time. Okay, so I know I said it would probably not be in the same video because it would take a while. It turns out there's actually very little left to do, so I am going to edit myself back in despite what I'm pretty sure I said just moments ago. The problem was not with my solution exactly, so to speak, but with my reading comprehension of the problem. I didn't read what it is they were asking me to do. They're not asking in what order will the steps be done, because although that is different, like, I don't know, maybe you could figure it out somehow. But the question is, how long will it take to complete all of the steps? So there was very little to actually change, and I'll just show you the git diff here. This is it, compared to what we had before. I just changed rule set to return an int. The base case is 0 instead of empty string. I no longer cons C onto the result when I start a task, and advanced time adds 1 to the result. That's it. So we were pretty much there. Just needed to double check what the rules were, and actually the algorithm was correct as written, which is sort of remarkable, despite being because it's like kind of a mess, right? I'm not like super thrilled with this. It's fine, but like I would love to hear if there's some Haskell expert out there watching this. How was I supposed to have done this gross ass pattern match where you like alternate between a guard or a pattern match on something that's not in like some other value, and then like more guards on that, and pattern match on another value. It just felt terrible. So, I don't know. Anyway, then now we're really done. Thanks for watching, and I'll see you next time.